Okay, so we discussed for probability, right? So find a probability for this thing happen. We have this formula, right? Equal. So here the total number of all cases in T, and here is in A. So find the probability. We just need to count how many this case, how many that case, right? So sometimes we just need to focus on find how many or count. So okay. So we have some problems just focus on counting, just find how many. Okay. So now here let's talk about some problem about like how many ways. Okay. So here we say the problem: 5 people stand in a line to take a picture. Just like A, B, C, D, E. We have there's 5 people. So could it be A, B, C, D, E? Also could it be like B, A, D, C, E, right? So the question is how many totally, how many of those ways? So we can regard this problem. So problem is that we have 5 positions. First one, second one, like that. So for first one, we just from the 5, we just pick one to put here. So could it be A, could it be B, could it be C, or D, or E? So first position, for the first position, we have 5 ways, right? Okay, so once we put the first position, then check the second position. So by now we have 4 people, right? So then from the 4 people to pick one to sit in second position, second chair. So how many ways? So we can pick this guy, right? So we have 4 ways, right? Okay. So now for this position, so by now we have 3 guys. So pick one to sit here 3 ways. And then we have 2 guys left. So from the 2, pick one guy to sit here. Then last one, this one, just we have one choice, just sit here. So how many ways? Just 5 multiply 4, multiply 3, multiply 2, multiply 1. So we denote this is 5 factorial. Okay, 5 factorial. Okay. So now let's consider this problem. We use these 5 digits, 1, 2, 3, 4, 5. We want to find, use these digits, how many, let's say, how many 5 digits number we can make. So this equal first position, like we just say, okay, first position, just like that, right? We have 5 positions. First position, we can from them just pick one to put here. So how many ways? 5 ways, right? So then by now, suppose the first one is this number of 3 put it to here. So then by now we have 4 digits left. So from here pick one to put here. So how many ways? 4, right? So we say here is just like how many 5-digit numbers? 5 factorial, right? Okay, so like from the 5 digits, we can make 5 factorial numbers. So this problem and the previous one had the same. 5 people sit in 5 chairs, 5 positions. How many ways? 5 factorial. Okay, so now let's consider those things for some conditions. So here we want to find how many 5 digits number, but this even number. Okay, so if this 5 digit number is even, so this means the last position should be even. So could it be 2 or 4, right? So last one should be 2 or 4. So we just check the last one. So here we have 2 ways, right? We just check the last one first. Last one 2 ways. Then here we put like one of them to here. Then by now we have 4 digits, 4 numbers, 4 digits. So put the 4 digits into the 4 position. So this is the 4 factorial. So five numbers, 5 people to 5 position, 5 factorial, right? So 4 number, 4 position, 4 factorial. So let's say how many those even numbers. So we say this is factorial of 4 factorial multiplied 2 or 2 times 4 factorial. Okay. So this time we want to find how many 3-digit and even number. So this is like 3-digit. Okay. So from 1, 2, 3, 4, 5. So this is 5 digits. So how many 3 digits number we can make? But this is even number. Even. So at the first we say last one should be 2 or 4, right? So last one we have 2 ways. So we put the last one first. Okay, so then here we have 4 digits. 4 digits, like let's say like we have 4, then put the 4 number digits to these 2 positions. So there's a position, first one we have can be from 4 choose 1, so can be 4 ways, like could be A, B, C, or D, right? We have 4 digits, like could be like 1, 2, 3, 4, or 1, 2, 3, 5, like that, right? Okay, so this for the position we have 4 ways. Then this position 3 ways, right? Okay, so totally how many ways? Just 4 multiply 3 multiply 2. Okay, so now let's check this problem. A 3-digit number. So 3-digit number we can regard 3 positions. So those number multiple 5. So if there's multiple 5, so we know last digit should be 5, right? So we should put 5 here. So last one way. Okay, so we put 5 last position. Then for these 2 positions we have 4 of them. So from 4 choose 2, put these 2 positions. So we can say first position we have 4 ways. Then this one we have 3 ways, right? So in this case, how many those numbers? We have 4 times 3 times 1. We have so many numbers. which is 12, right? We have 12 such 3-digit numbers that are the multiple of 5. Okay. Okay. So let's check this problem. How many integers between 1000 to 9999 have 4 distinct digits? Distinct means cannot be the same. So cannot be those number 1, 2, 2, 3. We cannot have those number. We should not include those numbers, right? Okay. So these digits are different, distinct. So this keyword, distinct. Okay. So we just have the 4 positions, right? And the first one, so we just check first one, should be 1, 2, 9. Yeah. So first one, we can put any of them to the first position. So how many ways? 9 ways, right? So second one. The first one cannot be 0. Second one can be 0. So second one can be 0, 1, 2, 3, 9. We can put 10. We can put we have 10 choices, right? But if first one is 2, second one cannot be 2. So second one, we have even though here we have 10, right? But distinct, but it should not be same as first one. So we have 9 choices. Like if first one is 2, then second one we can pick 1 or 0, 1, but it cannot be 2, right? So 3, yeah, okay, or 9, okay. So totally we have 9 possible ways. Okay, so then how about the 31? So 31 we still can be from here. So we have 10 choices, but cannot be same as this one, right? Cannot be same as those previous 2. If first one, let's say first one is 1, second one is 2, then 31 we have only 8 cases, 8. So now suppose 31 is 0. Then how many? The first position. First position. So cannot be 1, cannot be 2, cannot be 0. So can be only 7, right? So how many those numbers? So equal 9 times 9 times 8 times 7. Okay, so should be this number. Okay. So here we little bit calculation. So but anyway, like this number last digit cannot be 0. And let's say 99991. So last digit should be 6. So not this one, not this one, should be this, right? So we just check the last digit. Okay. Okay. So for this problem, it says this school, this school's chess team consists of 2 boys and 3 girls. Okay. So a photograph wants to take a picture of the team to appear in the local newspaper. She decides to have them sit in a row. So we just have 5 people. So 5. So just sit in a row. Okay. So boy at each end. So this position should be boy. This position should be boy. Then those are girl. Go. Like that. So the question is how many ways? So let's check it. Let's put the 2 boys. So we put the 2 boys at the 2 position, right? 2 boys, 2 position. We have 2 factorial, or 2 ways. We just the 2 boys to the 2 position, right? Boy 1, boy 2. So could be this, the B1, B2, or could it be B2, B1, right? So we just simply use this notation, just 2 factorial. 2 people to 2 position, 2 factorial. 5 people to 5 position, 5 factorial, right? Okay, so then for girls, we have 3 girls. So 3 girls to sit there, 3 chairs, 3 positions. So we have 3 factorial. So what is 2 factorial? 2 factorial is just 2 times 1, 2. What is 3 factorial? 3 times 2 times 1. Okay, so answer is 12. Okay, so this problem is find the probability. But the probability here is quite the same as the counting problem. How many total, how many in this case, right? So let's say this is an integer between 1000 to 999 inclusive, means include them, is choose at random. So totally how many ways? So we just say from 1000 to 9999, totally how many numbers? So from this integer to this integer, how many numbers? So we just say this minus plus 1, right? So just equal 9999 minus this plus 1. So don't forget the plus 1. So let's say let's consider a simple problem, like let's say from 4 to 8, how many numbers? So 4, 5, 6, 7, 8. Should we have 5 numbers, right? So we just do this. 8 minus 4. So we need a plus 1 equal 5. Okay, so don't forget the plus 1. So this minus 8999 plus 1, 99. So this equal 9000, right? We have 9,000 numbers totally. So among these 9,000 numbers, how many is odd integer? And the digits are all distinctive. So we have how many those numbers? So those numbers are 4 digits, right? 4-digit number. So here we have two requirements: distinct and odd. Okay. So if there's an odd number, so this means the last digit cannot be even the odd number. Last digit could be 1, 3, 5, 7, or 9, right? Oh, last one, so we say last digit, we have 5 ways, right? So if last digit is odd number, then this number is odd number, yeah. Okay, so last digit, 5 ways. Then check this, so it's 3 digits, 3 positions. So first one at least between 1,000. It cannot be 1, cannot be 0, right? Should be 1 to 9. So first one we have 9 ways. Then second one can be 0, but it cannot be same as previous one. So second one still 9. And this one, third one, so this one cannot be the first one, second one. So here we have we made a mistake. Like let's say first one cannot be 9 actually. Like let's say suppose we just check this. Okay. So suppose the last one is already 3, so first one cannot be 3, right? So first one not 9, can only be 8. Can be 1, can be 2, cannot be 3, right? Yeah, should be 8. Okay. So then this position cannot be the 3, cannot be first one, but it can be 0. So 10 minus 2, so 8. And this one, so 10 minus 3 should be 7. Okay, so so how many those numbers, the odd number and digits are distinct? So we have 8 times 8 times 7 times 5. Okay, so then we just try to simplify. Okay. Okay. So for this problem, use the digits 1, 2, 3, 4, 5. We can form 125 digits numbers. So where does 120? Where does 120 come from? So this is just 5 factorial. 5 factorial, 5 multiply 4 multiply 3 multiply 2 multiply 1 equal 120. Okay. Okay. So the question is, what is the largest for such numbers? So largest number, we should put 5 here, right? 5. We should put the large number. What is the largest number? This 5, 4, 3, 2, 1. This is the largest number. Then we need 4 of them. Yeah. Okay, so we say this one 5, 4, 3, 2, 1. The first one, largest one. Then we say this one 5. How about 3, 4, 2, 1? Okay. No. Oh, no. We also can have this 5, 4, 3, 1, 2, right? So maybe this is second one. Okay, just check last 3 digits. 1, 2, 3, 2. Let's see, 3, 2, 1. Also, we have 5, 4. So, like, let's say 3, 2, 1. We have from here we have 6 of them. 1, 2, 3. 2, 1, 3. Right? Yeah. So let's say 3 and 3. Yeah. So then we have 2, 3, 1. Then 5, 4, 2, 1, 3. So I think the largest full number should be this, right? 5, 4, 5, 4. So largest ones 3, 2, 1. Then we have 3, 1, 2. Then 2, 3, 1 or 2, 1, 3. Yeah. Okay. So let's check this problem. It says a haunted house has 6 windows. In how many ways can George the ghost into the house by one window and leave by a different window? So they have 6. Okay, so can be into from this window, then leave from this window. So just cannot be enter and leave from the same window, right? So int 5 or 6 ways can be any of them int. So then leave can only be 5 windows minus 1, right? Yeah. So if there's no this requirement into the house by one window and leave the house by one window, how many ways? So this should be int 6, leave 6, right? Okay, so here the answer is different. That means this, right? Into the house, the ghost has 6 ways, but leave have only 5 ways. So together, the 6 multiplied 5 ways. Okay.